Yeah, hi everyone. Welcome back to the new semester. I hope you had a nice summer break. So, in this brief video, I want to just go over some of the course material and we'll talk about how we are going to work together in this course because it will be a little bit different than a usual course where we have in-person sessions. So, for this course, my plan is to record the lectures asynchronously. That means I will record them ahead of time and share them with you at the beginning of each week so you can watch the material whenever it's most convenient for you. And I think this is useful to you because instead of doing it live, this way you can watch them whenever it suits you best. And you can also watch them multiple times if you need to. And also some of you may have slower internet connections, so you can download the video to your computer so that you don't have like streaming issues during watching each video. To make this a little bit easier, I'm trying to break down each lecture into multiple videos by topic. So by that, what I mean is I will, for each lecture, have like these different topics here. So I will, in this lecture or in this first video, just talk about the course in general. So a little bit about the syllabus, the topics we are going to cover and so forth. And so then I will talk about what machine learning is, what the different categories of machine learning are, notation, approaching a machine learning application and so forth. So these are all the topics of lecture 1 and I will divide that up into six videos. Yeah, and with that, I mentioned we will have the lectures asynchronously. One disadvantage is of course that you can't ask questions during the lecture, but I will have live office hours, so we can talk live over office hours. And I will talk a little bit more about the details in a second. So let's get started with lecture 1 and I will go through my slides and talk a little bit more about the course and the other machine learning related topics. So first, let us start with the course itself. Let us talk about the course contents and what we are going to do this semester. So I divided the semester into 7 parts. We will be spending a lot of time together until mid-December. So I thought it makes sense to split it up into kind of parts or modules here. So in the first part, I'm going to give you an introduction, like explaining you something about the course, like right now, talking about machine learning itself, and then also giving you a simple example of a machine learning algorithm called k-nearest neighbors. After you got a taste of what machine learning is, I'm going to cover some of the computational foundations, and with that, I will give you a very, very short intro to Python, and then talk about NumPy and scikit-learn. So most of you have taken introductory programming class. That is one of the requisites for this course. The course in this course we'll be using Python. Although I know not everyone has experience with Python, it's, I think, very easy to learn. There's a reason why Python is so popular. It's probably the most easiest programming language to learn. We will not be using Python very extensively. We will be using Python extensively, but I mean that we won't use all of its features. So for this class, it will be sufficient to have a very basic understanding of Python. Because most of the time we will be using specific libraries in Python. That is NumPy, which is a linear algebra library, and scikit-learn, which is the main machine learning library that we will be using. We will be implementing some machine learning algorithms from scratch using NumPy. And there are also some other libraries that will be important, like matplotlib for plotting graphs. That is something we will see then in part 2. And as a voluntary homework exercise, I highly recommend it also. I will post some interactive exercises on Canvas that you can do to prepare yourself if you don't have Python experience yet. But don't worry too much about it. Usually all the students did fine. In previous years, instead 479, students who didn't have Python experience, they were able to learn it like in a couple of days. So of course they were not expert programmers, but that's also not required in this course because the focus is more on machine learning. Okay, after the computational foundations, I will talk about tree-based methods. That means decision trees, random forests, gradient boosting. These are certain types of ensemble machine learning algorithms and so forth. After the tree-based methods, we will talk about model evaluation. I think that's a very important topic, which is why we will be spending quite some time on that topic. And the reason why I think this is important is that it allows you to compare machine learning algorithms and models fairly. So if you, after this class, want to learn about some other algorithms or train some models and you want to use them in a real-world application, you usually want to know which model performs better or which algorithm you should consider and how you compare different algorithms. So for that, we need to evaluate models and algorithms, and that will be covered in part 4. After part 4, we will go to part 5, dimensionality reduction and unsupervised learning. Don't worry about the term unsupervised learning yet. It sounds maybe a little bit fancy right now. We will talk about that shortly in this lecture. So just for context, this will be largely supervised learning, and then we will have unsupervised learning here. After that, I hope we will have some time left so that we can cover Bayesian learning. So Bayesian learning, that's like here an umbrella term for just methods relying on Bayes' theorem. So with that, what I'm planning to talk about is Bayes optimal classifiers, but also naive Bayes classifiers and also Bayesian networks if there's time. But yeah, I hope we will find the time. If not, well, I will probably just give you a brief taste of Bayesian learning, but we'll see how the semester goes. And then at the end of the semester, we will have your class project presentations. I will talk about the class projects more later in this semester, but I will also give you a short overview of what that means in a few moments. Because I just uploaded the website, the course website here, where I also have some more information about everything related to this class. And we can go through this briefly. I highly recommend though that you also carefully read through this document and then also ask me any questions during office hours or on Piazza. For that, the reason also why I made this an online website and why it's not on Canvas is there are currently many students on the waitlist, and the waitlist students don't have access to Canvas yet. So I thought for those who still on the waitlist, it might be good to have this resource in a way that they can also read it. Anyways, let me go to this link and talk a little bit more about the course contents. Okay, let's see what we have here. So there's a lot of content. So you can see there's a long table of contents here on this website. I recommend reading through all of it, but let me just give you the highlights here. So at the top, because that's usually what people mostly ask about, these are the course topics, and it's not really a calendar, it's just like my lecture. So I have lecture 1 to lecture 19 mapped out here, so that's my plan. It's just a more detailed version of what I've shown you in the slides. So the 7 parts: introduction, computational foundations, and so forth. The course description, that is something you probably already have seen in the course syllabus, the one on enroll.wisc.edu. So I don't really need to go through this, because if you are already enrolled in this course, you probably should know about this. Okay, next, course information, resources, and communication. That's the important part. So for this course, we will be using Canvas. So I thought just using fewer technology or fewer tools will make it, I guess, more manageable for you, because you will be taking several classes, and having all the content for one class in one Canvas course maybe makes everything a little bit easier for you. So if I go to Canvas, I don't really want to leave the site here. Okay, not sure what's going on. Let me cancel this and go to Canvas manually. Alright, Canvas seems to be slow today. Great. So 451. So I will just show you the student view for now. So right now what you can see here is the menu bar. That's the important part. And for every week I will post the material under like this module thing here. And right now there's only my welcome message and a little getting to know you quiz. So here I just set up a simple quiz where I'm just asking to introduce yourself, which is I think nice so that we can get to know each other in the context of this course. So that helps me understand what your programming background is and so forth. This is not graded, this is a voluntary quiz, so you don't have to complete it, but I would really appreciate that. So it's just some basic information, what you think about machine learning, what your background is and so forth. But again, this is not graded, but it would just help me to understand my audience, because this semester is a little bit weird because we have everything online and not in person. So just to make this a little bit nicer to getting to know you, would be nice if you could fill out this quiz. Okay, yeah, so most of the information, like I said, will be on Canvas, and that's also including lecture videos and so forth. So like I said, I will have these modules here set up. You should just, if you go to home, you should just see the modules. Let me leave the student view for now because I already prepared the lectures for week 1. It is really slow here. Huh. Okay. So this is also just an explanation. While I just mentioned everything will be on Canvas, there will be links to, let's say, GitHub files. For example, the code examples and homework, I will upload them to GitHub because they are coding files and it will be easier to view them and also update them. GitHub is a very common way for machine learning researchers to share their code for their papers, for their research papers. So I really think this is also useful for you to familiarize yourself with the typical environment that a machine learning researcher would work with. Alright, so what I wanted to show you is week 1. So I will create one page, one Canvas page for each lecture content for each week. So this is week 1, and after that I will at some point create week 2, week 3 and so forth. Right, while it's loading, I can maybe talk a little bit more or scroll through here. Yeah, also assignments will be submitted through Canvas. Important announcements here I will also make via Canvas, because I think UW is retiring the whisk.lists system, the emailing lists. So in that way we will use Canvas announcements. You can click on the announcements to see all the announcements, but also check your emails. So every time I send out an announcement, you should receive an email. If you don't receive an email, if you haven't received the email for the latest announcement I made yesterday, please check your Canvas settings so that you also receive these emails. There may be at some point something important to share, so it would be good that if you keep up to date with announcements, there could be something like I don't know what yet, but there might be something important at some point. So please enable the notifications for the announcements if you don't, or if you didn't get this announcement yesterday. If you got it, then it means your announcement notifications are enabled. So this is, I'm going back to the pages, week 1, the lecture overview for week 1. So I will post links to the slides and to the lecture notes. The lecture notes you can read after the class. Not every week will have lecture notes. It's just for your convenience. So for some lectures I wrote my lecture notes first and then I did the slides. So this is why I have them, but for certain weeks I won't have lecture notes. Yeah, I recommend downloading the slides before you watch the videos so you can take notes on the slides. Usually students find that very helpful if you can, or if you take notes on the slides or next to the slides. Yeah, and then I will have the videos. And you can see here things are not working. This is because we are in Safari here. I tried this option 3 here, but it still didn't work. So what I recommend for Canvas for this class or in general is using Firefox or Chrome. So I have the same page here, and I will show you that this hopefully works. Okay, so usually the videos should load now. Also, I should mention, yeah, there we are. So last couple of days I also had problems with loading the videos on Canvas because this is using Kaltura Media, and I think this is because the semester started at a lot of universities at the same time, and I think either Canvas or Kaltura Media was a little bit overwhelmed by the number of people using it. So I will probably also upload, at least in the first few weeks until they sorted things out, I will probably also upload the videos to YouTube. So as an alternative backup link. So if for some reason Kaltura Media doesn't work in Canvas here, then you can also watch them on YouTube. You can also download them here. So if you have a slow internet connection, you can download the videos, and once they finish downloading, you can watch them on your computer. You can also, for most of them, you should be able to control the quality. Okay, I'm still in the process of creating this first page, so this is why it looks a little bit different. There are two versions, one with the download button and one without the download button. But I will add the download button for all of them. And yeah, I will, of course, the video I'm recording right now, I will insert it here. Yesterday I already recorded it, but I disconnected my good microphone. That means I have two microphones that was just using the built-in one, and the quality was so poor. I first posted the video, but then I thought, okay, I will just re-record it because it was so bad. Okay. Yeah, anyways, I will add the video I'm recording right now right here, and this will be the first week's content. Okay. There will be some homework at the bottom, so I will also add some homework. Next, questions. So for questions, we will be using Piazza. So Piazza is a forum that is also embedded in Canvas. Let me go to the Firefox version. So if you go here to the left-hand side, there's a tab called Piazza, and this is just an online forum for asking questions. And for general questions, it would be great if you could use that. I really prefer that over emailing me because I get so many emails every day from all kinds of people, so that that I don't always keep up with email. I'm not able to because otherwise I wouldn't find the time to make the lecture content. So, but I will be checking Piazza, and on Piazza there are different options. You can post things to the entire class or to individual students or instructors. So I prefer, if you have a general question about the course, to ask that for the entire class. That means everyone will be able to see the question, because often students ask questions that are important for everyone. For example, if there's a question, hey, can you clarify when the exam is, or something like that, it would be useful for other students to know that too if they had a question, so I can answer it and other students can see it. Or if you have a question about the lecture content. However, if you have questions that, let's say, include partial solutions to the homework or your homework solutions, and you want to show me some aspect of it, then please don't share it with the entire class. So don't share solutions with the other people in the class. For that, you can use the instructor here. So you can, I think if you type my name, if you type my name here, you should be able to ask me the question directly. All right. I think, let me type that. Not sure. I think because I'm an instructor right now, it doesn't work, but for you, it should work if you type that. Okay. What's next? Course logistics. Yeah, everything will be online. My name is Sebastian Rushka, if you didn't know yet. So I will be your instructor, and our teaching assistant this semester will be Jongje Yu. He will also introduce himself very shortly. I will have office hours every Thursday, unless there's an exception, from 4 to 5:30 p.m. And we will also be using the tool that is in Canvas. It's called BB Collaborate. It's a video conferencing tool. So you can find it also here on the left-hand side. So just clicking on it. Oops. And then, yeah, you will be able to join the office hours. I just see it says 5 p.m. I will change it to 5:30 p.m. All right. So this will be live office hours. So in that way, you can ask me questions live, interactively. Resources. So there's no required textbook for this class, but it would be helpful, I think, for you to take a look at certain chapters of the Python machine learning book, because for my lecture slides, I'm familiar with this book because I was writing this book, so I was using a lot of figures and topics from this book. So the lectures are kind of inspired by this book, but yet they are quite different. However, I still think the book would help you with certain aspects about scikit-learn and NumPy with regard to machine learning. I will, in each week, I will post also links and chapter recommendations. Python resources. So like I mentioned before, some students haven't worked with Python yet, and I thought it might be useful to have some basic resources for you that you can quickly brush up on your Python skills. So the ones I try to select one resource from each category. So there are video lectures. I thought these were really nice and accessible. A relatively new video series by people at Microsoft. It's available on YouTube. Then there are the interactive tutorials, Learn Python tutorials, and I will add this as an optional homework also, some of these exercises for week 1. And then if you prefer books, I found this Illustrated Guide to Python is a pretty accessible book. There's another resource, it's also pretty nice. It's Alan Downey's Think Python, the 2nd edition. There's a PDF version available here. And there's also Python Like You Mean It, which is also good online tutorial. But yeah, of course, you don't have to go through all of that. Just pick maybe one resource that fits your learning style best. Regarding the grading, so there will be the problem sets, exams, and class project. So problem sets will be homeworks, but I will also make some small quizzes throughout the semester. The exams, there will be one midterm exam and one final exam. More on that later. And the class project will be divided into 3 parts: a project proposal, a project presentation, and a project report. And I will also talk more about this later on. Here's a little bit more about the planned grading scheme, but of course, due to COVID-19, it's a little bit hard to predict how well you all will be doing online this semester compared to, let's say, the regular in-person classes. So if I notice, for example, that the grades are really bad this semester for some reason, I will also consider curving the grades this semester. But we will be using this grading scheme unless maybe I notice there's something weird about it. I just see I should update this. This should say 920, 880, 840 and so forth, because the number of points is 1000 in this class and the percentages are corresponding to that. So dividing this number by 10, then you get the percentage. And you can see this was what I was planning to use, but because of COVID-19, I lowered the threshold from 93% to 92, from 90 to 88, and from 85 to 84, but I just forgot updating it. I'm making a note here on my piece of paper, so I will not forget updating the grades. Okay. Exams. So the exams will be at a specific time. This would be our lecture time if it was an in-person session. So the midterm exam will be on Thursday, October 15th, between 4 and 5:15 p.m. And I will set it up on Canvas as a quiz. And the final exam will also be a quiz on Canvas, and that will be on December 14th, Monday, between 10:05 and 12:05 p.m. For the class project, that is usually the most fun part. This is what students like most about this class also. It's usually the part that is mostly creative, where you get to design your own machine learning project, like a little research project, and then you will work with 3 students or in a team of 3 students on this class project. And this entails writing a proposal. That's a 2 to 3 page proposal that is due mid-semester. I will give you the date later. And this is a proposal where you are telling me what you are planning to work on, and I will give you some feedback and tell you whether that's a good idea or not, or maybe also make some suggestions. And after the proposal, you start working on your project. I mean, you can also start a little bit earlier if you like, but yeah, after the proposal, you would start working on that project and carrying out what you proposed. And at the end of the class, the last couple of days of class, I will ask you to give a presentation for the other students. So we'll have it's like little conference talks where you present your project in a talk and then also submit a final project report, 6 to 8 pages, which looks a little bit like a small research paper. And for that, I set up some proposal LaTeX files. We will be using LaTeX for the proposal and the report because that will make things more consistent. And similar to using GitHub that I mentioned earlier, it will also introduce you to the real-world environment that machine learning researchers use. Because usually in statistics and machine learning, we use LaTeX to write our reports and papers. I will give you an example report. I will make a note. Report example, so that you can take a look at what other students did in previous semesters, so you get a better feeling for how the report will look like. But of course, the report is due at the end of the semester in 3.5 months, so don't worry too much about it yet. So these are just some grading guidelines for the report, the assessment and so forth. You can read through this later when the time comes. The project presentation, this will be an 8 to 10 minute presentation in class. So in this semester, it will be recorded and we will post that to Canvas. And here's just an example of previous talks that students gave last semester in the deep learning class. It's a slightly different class, but the format is very similar. And yeah, these students volunteered to have their talks on YouTube. Of course, this is not a requirement. This was just optional. Students wanted to have them on YouTube, so that was a nice thing to do. So you can take a look at this short introduction, some of the previous projects that the students worked on and how they presented them. All right. So there will be 3 awards, one Best Oral Presentation Award, a Most Creative Project Award, and Best Visualization Award. So other students will basically assess your talk, and then we will have some small awards, which is, I think, also a cool, motivating thing to do. Yeah, there's a lot of the assessment, so you can read through this later when the time comes. All right. So other important course information. So I will have a late submission policy this semester, and this is mainly due to maintaining fairness because some students work really hard to make the deadlines. So it would be unfair towards the students if some students submit things late. So for up to 6 hour late submission, there will be a 10% deduction of the maximum possible points. If you submitted 6 to 24 hours late, I will deduct 20%. And if you submitted more than a day late, more than 24 hours late, there will be no points for either homework or other class-related submissions. This is just to maintain fairness, because some students work really hard to make the deadlines, and it would be unfair towards them, if some students submit the homework late. Okay, then there are some other important considerations. So the rules, rights, and responsibilities, academic integrity, accommodations. So you should please also read through all of that. This is starting from here to the bottom. This is not something I have written. This is the campus guidelines. So chances are you have already seen that. If you have not seen that, it's very important that you read through this and are familiar with what we expect at UW Medicine, how you should conduct yourself in terms of academic integrity and what accommodations we provide, and also how we guarantee diversity and inclusion. It's also very important. So this semester we have, unfortunately, an online semester and the current challenges with COVID-19. So this is also from the campus guidelines. If you are new to campus and you have not seen this in another syllabus, please also read through these guidelines. Okay, with that, I will end the video now because it's already very long, but in future I will talk more about the class project, homeworks and so forth when the time comes. I just don't want to overwhelm you at this point yet. All right, then I will see you maybe at the office hour on Thursday.